All right. Now, for the last video, I just thought I'd give you some review problems for Ohm's law and power, and we'll see what you guys understand and what you might still have questions on. So, in this first circuit, we have a battery, we have an ammeter, ammeters here, 27 ohm light bulb. There's a switch, and the battery is 12 volts. Notice that the switch right now, it says infinity ohms. That's because it's open. So it has so much resistance when it's open that current can't travel through that switch. So now what I'm going to have you guys calculate is the current. When I close the switch, I want you to tell me what the current in the circuit is. All right, so now I am going to close the switch. We'll see if you're right. Notice also when we close the switch, it's now 0 ohms, so there's no resistance. And so 0.44 amps is the current in this circuit. All right, now for the next circuit, here we have same thing, except it's just a different orientation. I changed the numbers around a little bit. So 100 volt light bulb, 43.5 ohm light bulb, 100 volt battery, 43.5 ohm light bulb. There's the ammeter and then the switch. So let's calculate the current, and then I'm going to have you calculate the power as well. But let's do the current first. All right, so now 1.85 amps is what we got. But when you calculated it with the numbers that I gave you, you probably got about 2.30 amps. So how about if you think about why the current that's actually showing in the ammeter is different from what you calculated? All right, then in the third circuit, this time I stuck a fuse in there. So given this information, we have a simple circuit with a 15 volt battery, a switch, 3.5 ohm light bulb, and then a fuse, which is rated at 4.0 milliamp, or 4.0 amps, which means that the amperage cannot exceed 4.0. On these fuses, you're also given 15.0 milliohms for the resistance of this fuse. We're going to assume that this is really small compared to the bulb, so that you don't need to consider this 15 milliohms in your calculation. And then also I'll show you this so you can see that the battery resistance is set to 0 and the wire resistivity is tiny. So this time we can ignore it. When I close the switch, I want you to figure out, I want you to figure out if the fuse is going to blow when the switch is closed. So hopefully you said yes, because you got a current, with these numbers, you got a current that is greater than 4.0 amps. And so now the fuse shows a resistance of infinity milliamps, which means that it's basically like an open switch because this has been broken. All right, so if you understand those problems that we just, that we just did, then you should be in good shape for the series and parallel lab for this week. If you still have some questions about it, it would be great if you can come to office hours this week. And this week they're Wednesday and Thursday because of the holiday. All right, that's it. Have a great week.